Greetings and welcome, friends. Today we're talking about polynomials. That's right. Good stuff, good stuff. So I've got a couple definitions here just to talk about real quick. A polynomial is a many-termed expression. We talked about terms a little while back. A term is made up of variable, potentially, its exponents, and the number in front being a coefficient. Okay? So a polynomial is more than one term, all right? Although technically single-termed expressions are a subset of the polynomials as well. But so let's talk about that real quick. So polynomial is a multi-termed expression. So let's write down just a little example of some polynomials, and we'll talk about the vocabulario related to these friends. So here's three polynomials, right? So 2x plus 1, there are two terms here, 2x and the positive 1. All right, so a term is the variable, coefficient, and its exponent for the variable. All right, so there's two terms there. Here's 1, 2, and 3 terms. The terms include the sign, by the way, in front of them. So this is a 3-termed expression. And here's a 4-termed expression. All right, just so you understand what I mean by terms, right? Goody goody. So the degree of a term is the sum, meaning add, of its variables' exponents. All right. I wonder if I need a little possessive s or something like that on that, but that's fine. So for instance, the degree of this term, this variable has a little invisible 1. The degree is 1. The degree of this term is 2 because this variable is second degree.
And 1 under is 5.
And this is a 5th degree term. Now if I had a term like this, 2x squared y to the 4th, what's the degree of that term?
The term is 2.
Well, this whole thing is a term, actually.
The degree is 6.
The degree is the sum of the variables is exponents. Bow, 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 bow. So the degree of a polynomial is the highest degree represented in the entire polynomial, right? So here's a degree of 2. Here's a degree of 1. Here's a degree technically of 0, because Emily, you of course know that anything to the 0th power is 1. So yeah, for constants like this, you can just imagine that there's an x to the 0, x to the 1, x to the 2nd, right? Stuff like that. But the degree of the polynomial would be the highest degree present amongst them all, the fairest of them all, so to speak.
Does 3 have a 1?
This 3 technically does have a 1 there. But when I talk about the degree of a term, I'm just talking about the variable's exponent, not the coefficient's exponent. But that is a good thing to point out. There is technically an exponent there. So let's see. The leading term is the term with the highest degree. So what's the leading term here?
X.
The 2x, the entire term, is the leading term. What's the leading term in this one?
3x squared.
3x squared is the leading term because it's the term that had the highest degree. And the leading term here
2x to the 5th.
is 2x to the 5th. So that entire thing is the term. But if I asked you what the leading coefficient was for this polynomial,
Would be 3x squared.
for this polynomial,
Negative.
the leading coefficient is the coefficient of the leading term.
Oh,
So the leading term was this, so the coefficient is just the 2. All right? So that's the difference between a leading coefficient and a leading term. All right, leading coefficient, leading term, leading coefficient, leading term, right? Good stuff. And then like terms, this is going to come into play later, are terms with exactly the same variables and exactly the same exponents. So if, let's say, now none of these problems have like terms within themselves. All right, these are all unique terms. But out of all 3 of these, what's a like term with 2x? In any of these other problems?
What are you asking?
Well, like terms are terms with exactly the same variables
Oh, so 5x.
and exponents. So negative 5x is a like term with the 2x. What's another like term?
Oh, negative 3x.
No, that one's squared. It's got the same variable but not the same exponent, so just the plus x. So those 3 would be like terms there. All right, like terms would also be like the plus 1, the minus 1, and the minus 7. Those all have no variable, so to speak, all right, or an x to 0 if you want to think about it that way. What about 3x squared? Where's its like term?
Negative 3x squared.
Negative 3x squared. Very good. So, so that's just some of the concepts and vocabulary regarding polynomials. It turns out there's also this concept of naming polynomials. All right? And polynomials, like people usually, actually have two names. I'm spelling that wrong. Nomial. Naming polynomials. The first way to name them is by degree. Okay? And we're going to make this little tablature. Nice little 3-column table. This one will be the name. This column will be for the degree, and the degree column can be skinny. It's just a single number. And then the third column will be some examples of that. All right, all right. So if I have a a 0th degree polynomial, we've already talked about those. Some examples of that would be like the number 2, or the number -1, or the term 5, right? Or actually, better yet than 5, let's make it the square root of 5. All right, any term that is a single number where that's the whole polynomial, all right, it's technically a monomial in that case because it's a single term. The highest degree here is a 0 because all of these have like an x to the 0, so to speak. And what these are called is constant. All right, they are constants because think about it, they don't have a variable. Variables vary or change. Constants don't change. They're constantly the same.
Like our balloon in our project is a constant.
Okay, sure. So, so how about a first degree polynomial? That would be something like 2x, or like negative 3x plus 8. All right, something like that. So there's two examples of first degree, right? First degree because the highest degree present is 1. Does anyone know what these ones are called? Linear. And if you think about it, that makes sense because the graph of this type of polynomial is actually a line. It's linear than most graphs. Right? Because if you think about like y equals mx plus b or something like that, that's technically a linear function. All right, so this is a linear polynomial when it's a first degree.
It can only go in one direction. It can't change direction anywhere.
True, true. Yeah, it's constantly heading in one direction. I like that. So let's see. A second degree polynomial would be something like x squared minus 4, or maybe like 2x squared plus 5x minus 7.
Oh, I get the power.
Right, so by degree I'm talking about, yeah, the highest exponent present. So second degree, I'm referring to these guys right there. Does anyone know the names of these ones? You might recognize this from Math 1-ish or something. These are called, and this is a deceptive name, I think. They're called quadratic. And it's tricky because you'd think quad means 4. And you're right, quad does mean 4. But the reason these exist is, well, if you think about if I had like a rectangle or something with 2x and say like, let me simplify that. If this was x and this was 3x and I want to find the area of this quadrilateral, I would multiply the dimensions and that would give me 3x squared. And notice squared right there. So it's actually related to the area of a quadrilateral, oddly enough there. So those are called quadratics. And once again, don't get tricked by the quad there. All right, third degree polynomial would be like x cubed plus 2x squared minus 5x minus 1. But it also could be something as simple as 5x cubed, right? Something like that. As long as the highest degree is 3, these are called cubic, and similar to what I was just talking about a moment ago with a quadrilateral. Imagine I have a 3-dimensional figure, maybe a cube, maybe not. x times, say this is 2x. If I wanted to find the volume of this figure, I would multiply all of these. X times x times x is x cubed, right? So the volume would equal 2x cubed in this case. All right, so that's literally referring to the volume of a three-dimensional solid. So that's why they call them cubic as the name there. Let's see. We'll go a little further. Fourth degree, something like x to the fourth minus 2x, right? Or just 6x to the fourth, something like that. And a fourth degree, you would have thought this would have been called a quadratic, although it's called a quartic. And you could think like a quart, 4 quarts in a gallon, or a quarter, 4 quarters in a dollar. Dollar, right? So yeah, quarter, you can think about that. Fifth degree, this will be the last one we refer to as x to the fifth minus 2x plus 1, let's say. So a fifth degree polynomial is called a quintic. And from that point on, if you just have a polynomial of degree n, you just call it an nth degree polynomial, is literally the name that we give it. So if I have a 12 for my highest degree, I would say that's a 12th degree polynomial. All right.
Anything after 5 is that?
Yeah, sure. Some of them might have names, like for instance, I could call a 6th degree a hexic, which is also the name of the classic puzzle match game that came pre-installed on the original Xbox 360 consoles, invented by a Russian gentleman currently working for Microsoft, who is also the inventor of Tetris. Crazy stuff.
The inventor of Tetris works for Microsoft.
Yeah, nowadays he does. Yep,
Do you
good.
think he wouldn't have to work?
Well, maybe he enjoys making puzzle games. So let's see. So these were all classifications by degree. So this would be like the first name of a polynomial. The second name would be by number of terms. Number of terms. So let's make another little chart. 3 columns again. Name. I'll say number of terms. This will be a shorter chart. And then we'll have some examples again. Exemples. There we are. If I have I can't have a zero-termed expression because then it just doesn't exist. But if I have a single term, you guys have already seen those before. That would be like 2. That would be a constant, right? Or I could have even like something like this, 3x squared, right? Something like that. Or negative 4x squared y. These are all single terms, and we already know what these are called. These are referred to as monomials. All right. Constant is a name for degree of 0. Monomial is for the number of terms being 1. All right, 2-termed expression. That would be like 3x minus 5, or like 5x squared minus 2x, right? There's just a total of 2 terms. It's unrelated to the degree. All right, so just to specify so you know what I'm talking about, right, I'm referring to 2 terms here, right? 2 terms. And the name for that one is binomial. Bi being the prefix for 2, right? Like binocular, bicycle.
Next one, trinomial?
Oh, what? What?
Oh. Yeah.
They shouldn't even call it trinomial. They should just call it monomials, because you should have named it after yourself. So let's see. X squared plus 2x minus 1 would be a trinomial, right? Something like that. But it doesn't necessarily have to be degree 2. It also could have been like x to the 7th minus 5x squared plus 4, you know. But the point is that these have a total of 3 terms present, right? Tri, as in like triangle, 3. You get the idea. And it turns out anytime I have 4 or more terms, 4 and up, x cubed minus 4x squared plus 5x minus 7, let's say, is one example. So 4 terms total. Get ready for this. This is really weird that they named it this. Polynomial. So
Poly means many.
poly means many. You got it. So within the classification of polynomials, they also have a subcategory called polynomial. Right? That'd be like if when they made the animal kingdoms, they had like, all right, under animals we've got types of mammals, and within mammals we've got, you know, dogs, cats, and humans, and oh, we'll have another mammal called mammal, and like, come on, like naming convention. At least like use like classic internet naming conventions where you could have called it like mammal 1924 or like XX mammal XX, you know, or like something cool. Yeah, you know, if you're gonna use the same name, you gotta at least, yeah, use something different.
Spice it up a little. Make it like
Yeah,
polynomial.
No.
exactly. So let's look at just a quick little example. I'll just have you name the polynomial. Name the poly.
Is this like a game show?
It sounds like it would be.
Polynomial.
So if I wanted to name this polynomial, x to the third minus 5x squared. So the name for this polynomial, I first name it by degree.
Cubic binomial.
So it's going to be.
So it's cubic,
Binomial.
and it's got 2 terms.
So it's going to be a cubic binomial.
I like it. Cubic binomial. Well done. Well done. How about this? What if I've got a negative 5x squared y plus 2xy and then minus y? Yeah, that's good. That's good. All right. So what's the degree here?
It's a quadratic trinomial.
Well,
The degree is
technically
4.
3.
So
It doesn't include the degree of the constant. It's the sum of the variables.
I
All right.
put a 2 after the
Cubic.
1.
The degree of this term was 2. The degree of this term was 1.
cubic trinomial.
So it's cubic, and the number of terms is 3. So yeah, trinomial. Right. So you guys get the idea. So it's like a first name, last name sort of thing. Right. Classified by degree and then the number of terms. Right. No es más mal. No es más mal. So, let's take a look at another thought here. What if I want to add polynomials?
I don't know, man.
Well, adding polynomials is nothing too crazy. Well, a few different ways I could think about it. Actually, yeah, you guys already have your definition of like terms. But adding polynomials is essentially all you do is combine like terms, is how it's often referred to as.
Simplifying?
Sure, it's a type of simplifying. I mean, but they started off as 2 separate things. So specifically what we would do when I combine like terms is I add the coefficients and the degree stays the same. All right, they have to be like terms in order to do this. All right, all right. So combining like terms, like terms. So let's do a couple quick examples. So for instance, if I have 3x plus 2x, all right, here 2 monomials being added arguably. Are these, first of all, like terms? Are these 2 buddies?
Yes.
How do I know?
Because x to the first is the same as
Yeah, these are both x's. They both have the same degree. So if this was x and y, not like terms. If this was x squared and x to the first, not like terms. But the fact that they're the same variable and the same exponent, I can combine them as like terms.
5x.
So 3x plus 2x is 5x. So notice we added the coefficients, 3 and 2, got 5, but the degree stays the same. It's still x to the first. All right?
That's a linear binomial.
And that is a linear monomial once it was simplified, because there's only one term now. Yeah. Yep. Okay, let's look at this one. What if I've got 3x squared y minus 2xy squared plus 5x squared y plus y cubed? Crazy sauce, huh?
Well, I just wrote that as you said it. I didn't look up.
Hey, yeah. Excellent. So when I go through, first of all, how many terms are here?
There are 4 terms.
4 terms, all right? So these are the terms, all right? Terms are kind of separated by plus or minus signs. You can think about it that way. 4 terms. So for this first term, does 3x squared y have any friends I can combine it with?
Yeah.
Is this a like term?
It is not. Not for
Why not?
Because x is to the second power and x is to the first power.
Yeah, so even though it's the same variables, the exponents didn't match up. So yeah, the only other like term that it had was this. So how many of those do I have? I've got 3 and 5 combines to be.
X, y.
Yep.
And then you can.
And then does this guy have any friends?
No.
No, it's just all by its lonesome. And y cubed has no friends either. So yeah, so I've simplified this as I think Morrow said earlier. All right, so that's the idea. So last concept, here we go. What about multiplying?
And divide.
I'll say multiplying a monomial by a polynomial. Monomial, there we are. So in order to do this, what we do is we multiply the coefficients and we will add the exponents if the variables match. Okay? So multiply the coefficients, and if the variables match, then I'm just straight up using my property of exponents.
Does that mean that if they're like the same, what do you mean match?
Same base, same base. So they didn't necessarily have to start with the same exponent. And we'll do this one example and we'll be done. So in this case, this is also distributive property in a sense. So here's our example. I'm multiplying a quartic trinomial by a quadratic monomial, right? So what I do is actual distributive property here. All right, so everyone on the inside is getting multiplied by 2x squared. So 2x squared multiplied by 3x to the fourth, I multiply the coefficients, so 2 times 3 is 6. And x to the fourth times x squared, I would add the exponents. All right, so that's x to the sixth. 2 times negative 5 is negative 10. And x squared times x squared, property of exponents, I add them, x to the fourth. And 2x squared times negative 3, I multiply those numbers as negative 6. And x squared just stays the same. I didn't have any x's to combine it with. Nothing like that. And I don't have any like terms, so I'm done. By the way, if I wanted to name this, what would you call it? The answer here.
It would be a
You'd say sixth degree
trinomial.
trinomial. Right? Well done. So thanks for watching, Internet friends. Have a great day. Bye-bye.